Good morning. I hope you guys are in good spirits. So let's finally have a look at the remainder of this paper, just for completeness sakes. Otherwise, it's a fairly standard paper. So I skimmed and scanned these questions, and I think they are fairly easy. Sorry, but yeah, despite all of that, this is a teaching point. So let's teach you something so that you can see what is going on. Ideally, by now, matriculants should have finished the syllabus. So that means all the sections contained in this paper should be familiar. Okay, let's have a look at question 1. Obviously, be very careful of instructions like these because the rounding off becomes your nightmare. And it means if you use any diagrams, calculations, whatever, please show us, okay? Don't just show up with answers and you have not justified where they come from. You lose marks, all right? First question, statistics, easy stuff. And we know here we are definitely going to need to do the least squares regression line, because once we see bivariate data, it already tells us we're going that way, and we can see the scatter plot. Let's read. The number of pages in 10, how many are they? 10 A4 books and their corresponding weights in grams, again the measurement there, are given in the table below. The data is also represented in the scatter plot. Okay, we see that. Now, I don't really need to be reading any of these, so we can see that the number of pages translates to some weight in the book. So already we want to punch this into our calculator. We go to mode, and then once we get to mode, we hit the start option, which is 3. Then after that, we hit that option 2, which has a plus bx, and then we get our table there, and then we fill it in. Okay, let me just do it quickly. Okay guys, so I'm ready to go. So we can see that this is linear. Can you see? It's very linear, so this is a good correlation. So there has to be a strong positive correlation coefficient here, but we'll find out. First question, determine the equation of the least squares regression line. We expected it, so 1.1, we know that we need to find A, we need to find B, and then we write the equation. So let's do it. So here we just go shift, stat, shift, stat, and then from there we choose option 5, which is regression, and then we need to select A. So what is the value of A here? The value of A here, I'm getting minus 43.72 to 2 decimal places. All right, so we go again, shift, stat, and then regression, we choose B this time. What do I get? Getting 2.36. Can you see it's already a positive gradient? So that means our least squares regression line is going to be 43.72 plus 2.36 x. Okay, so the equation is complete. All right, so we score a mark for each one of those 3 things. Okay, we move on to 1.2. By the way, let's find what is our R. So again, we do the same thing, shift, stat, and then regression, and then we choose R. So I'm getting R is equal to 0.97. Can you see this is closer to 1? So this is a very strong positive correlation. Even this gradient, the steepness was already saying it. But usually the steepness is not the big deal here, but yeah. The R, I mean the scatter plot actually was giving it away rather than the gradient. Okay guys, let's not waste time here. This was fairly simple. It says now draw the least squares regression line on the scatter plot. So now we just need to select points that we can use to do that. So I just want to use points that I know I don't have here on the table, because if I use points on the table, it's going to be a bit nasty. So let's choose this one here and see what it gives us. So we want to choose points that are within the domain, okay? But not necessarily the plots on the graph, because the plots will mislead us in a way. Now, I can see there that I'm going in 5s, 5, 10, 15, 20, because that's 20 divided by 4. So if this is 100, this is 95. So let's just substitute 95 onto our equation and see. Minus 43,72 plus 2,36 into 95. That gives us 180,48. Okay, that is what we want to find when our x is 95. Now let's see, where is that? Now I want 180, so this is 150. I can see it's going in tens. 160, 170, 180, 190, 200. So 190, 180. So this is 180,5. So 180,5 is somewhere in between. Hey, Wenzantoni, man. So I want here 150, 160, 170, 180,5 is in between. So I come down to this line and then just go slightly above it. Just gonna place a point here. Obviously it's not gonna be accurate, but I have a point there. And then this is 200. We're going in 5s. It's 220. 120, 125, 130. And we can see it's not a plot in the graph, so it's 130. Now let's put 130 on the calculator here. 130. I'm getting 263,08. So this is basically comma 1. 263,1. So this is 250, 260, 270. So over, just above the line of 260. There is our other point. Again, it's not going to be exactly accurate, but we just want something that gives us exactly what we want, or at least something closer to what we want. So now all we have to do is to join those points. I don't have a ruler, guys, so you will do this with a ruler. So if I join my points like that, usually it doesn't matter really if you reach the x-intercept there or what. So if you've drawn a line that seems to be doing the things, that should be enough. So I think that's okay. So all I can do is just to make sure those plots are visible. So that is what we do. And then obviously the means to an end must go. They are not part of this. So that's fine, guys. We did our job. So 2 marks there. So all you can write here is to say C graph. Okay, so we go with our 2 marks. 1.3 says predict the weight of an A4 that has 110 pages. So that's fine. We know that we have this equation here. And then this is going to be 110. So let's see, what does the calculator say about that? what stories does it tell us? It says this is going to be 215,8 grams. Remember, this is a weight, so there must be a unit of measurement. Should it not show up, you are dead. Seriously dead. So this is substitution and answer. Nice and easy. 1,4 says now calculate the percentage weight increase between a book of 110 and a book of 130. So now all we have to do is to predict the weight for a book of 130 pages. Plus 2,36 into 130. So let's see. I don't know why I removed my equation. See now, giving myself a lot of work. Sometimes this thing of rushing is not right. So I'm getting 263,08 grams. Okay, that's an intermediate step. Now the weight increase is going to be from 215 to that. So we can say then the percentage increase is going to be this new weight minus the older weight. And then all of that we divide by the older weight because that's what increased. I don't know why my numbers have a tendency to just fade as I keep writing. And then we multiply that by 100%. Maybe let's move this stuff a bit. Chachella kwana. Skanjwetsa hore so liboteng jwalo liboteng lai times 100%. Okay. So let's get that percentage increase. So 263,08 minus 215,88 is that, and then we divide by 215,88. Then we multiply that by 100. It gives us 21%. 86. 21.86%. So this would be the percentage increase. Okay, let me just double check. 263,08 minus 215,88. That divided by 215,88 times 100. Yeah, it's 21.86%. I don't know where is the 6 here, because we are told to round up to 2 decimal places. Okay, so be careful of those things. Now that is great. So that prediction is good. This setup is good, and the answer. So that's how those 10 marks are scored. Okay, great. We then move on. So let's go to question 2. Now question 2 is still statistics. Usually we deal with grouped data or sometimes univariate data. So it depends what is presented here. Now let's have a look here. We are told here 50 athletes need to access suitable training facilities. The table below shows the distances in kilometers that they need to travel to obtain access to suitable training facilities. Okay, so you can see here that the class of 0 to 5 is 3 athletes, 5 to 10 is 7, and so forth. I don't need to explain that. So it says now complete the cumulative frequency column provided in the table. Now I don't have the answer book, so I'm just going to extend it here. So, but you will have a book to go and do this on. I don't have the time. So all I know is that this is the cumulative frequency column. So obviously the first one is going to be 3. Second one is going to be 3 plus 7, which is 10, plus 20, 30, plus 12, 42, plus 5, 47, plus 3, 50. Okay? And we already told there's 50 athletes. So once the last cumulative frequency value matches the total, then we know it's correct. So again, that's easy. So 2.1, we can see C table, and then easy 2 marks there. 2.2 says, on the grid provided in the answer book, draw a cumulative frequency graph in Ogive to represent the above data. Okay, now I'm just gonna do it quickly so that I can save time. This thing is a tedious process. To draw an Ogive though, here's the pointers. We always draw, we plot the upper values of each class with the cumulative frequency or the corresponding cumulative frequency value. So that's what we plot on the cumulative frequency graph or an Ogive. Okay guys, so I've drawn this one as quickly as I could, so it's probably not going to be as accurate because I'm not using a ruler. I don't have a proper grid, but it's a pretty easy thing to do. Okay, just make sure this thing is anchored at 0. Okay, great, or anywhere, but it has to be anchored on the x-axis. So we literally get our 3 marks there for everything. So that's the story. Now it says calculate the interquartile range of the above data. Okay, so we need to find the half. We know that half of 50 is 25, right? So from 25 we just go to the graph, and as we intersect the graph we go straight down. Looks like I'm overly extending it, so it looks like it's sitting there. Okay, so can you see this is just before 15, so this is perhaps 14, 13 corner lab. So that is basically half of the data, so that's the median. Okay, that's the median, that is Q2. Now half of the half is going to be exactly what we know. So it's what we know. So we're going to take half of the above data, which is 50 plus 20, and then we divide that by 2. It gives us 35. So 35, what did I say? 25, man. Plus 50, 75 divided by 2, it's 37,5. Now that makes a bit of sense. So 35, 36, 37, somewhere around there. We draw another line into the graph. Okay, obviously when you have the grid, all these lines are going to just be nice to do. Right now I'm just going to be struggling with doing these, but that doesn't look too bad, although it doesn't look exactly straight down. Try one more time. It's not too bad. I see yak. So that is our Q. This is our Q3, right? right? Because at 50 it's maximum. And then the bottom half is 12,5, right? So 12,5, we can say perhaps 12 there, 12,5 somewhere there. We go to the graph, and then we come down from the graph. They're not going to look exactly accurate into the slung. It looks a bit slid. Okay, that looks a bit better, but my eyes are just seeing what they are seeing. So that's what we have, guys. So this is just after 10. So this could be 10,5, could be 11. So let's just assume that this is approximately 11. So that is our Q1. And then Q2 is right around what you call 14, 13 Konalabo. And then this one is between 15 and 20, maybe around 18, 17. So let's just choose 18 here. So the one thing about this question, they're fairly easy, but you do a lot of work. So now we want the IQR. So the IQR is going to be basically Q3 minus Q2. So this is 2.3. So the IQR is basically Q3 minus Q1. So we estimated our Q3 to be 18 minus 11. Obviously here one would have a range of values. So I'm getting 18 minus 11. So that gives me 7. But remember, this is pages, right? Because that is pages. But the range, yeah. It's on the x-axis, so that's the story. That's the story, because the data we are studying here is the kilometers. Oh, why am I talking about pages now? I'm still in the previous question. Goodness. Kilometers. So this is going to be approximately 7. Obviously, guys, this is an approximation. It's not an answer. It's an approximation. It's an approximation. So that is the best I can do. Obviously, with an accurate sketch, you would get the right values. But for now, we just do what we do. Okay. How much? 2 marks here. So obviously, we're getting a mark for those estimates, and then we get a mark for the answer. Now, we are told here that the families of 4 of the athletes above who stayed between 15 and 20 kilometers from a suitable training facility decide to move 10 kilometers closer to the facility. In which interval will the number of athletes increase? So obviously, where did they belong? Between 20 and 15 kilometers. Now you can just pick any number between 20 and 15. Take 17, for example. And then you subtract 10, because if we're moving 10 closer, it puts us at 7. 7 is between 5 and 10. And obviously, 15 minus 10 is 5. 20 minus 10 is 10. So obviously, this already tells us that if these people are in between 20 and 10, they will fall between 5 and 10. So the interval that is going to have an increase, so it's going to be 7 plus 4 now. Okay, so that would be that interval. So it says now in which interval. So 2.4, it's going to be the 5 greater than or equal to, x is less than, x is greater than or equal to 5 but less than 10. That would be the interval, so just 1 mark. Okay, so that's easy, guys. And then we are told here to calculate the estimated mean distance that the 50 athletes need to travel after the 4 families have moved 10 kilometers closer. So we know that now something is going to change here. From 12, we subtract 4. We'll assume there's only one athlete per family because they didn't tell us. So there we're going to have 11 now instead of 7. And then here we are going to have 8 instead of 12 now. Okay. So that is just the changes. But the totals is going to remain 50. That's what matters here. But in any case, we don't need the cumulative frequency anymore for this estimated mean. Now, for the estimated mean, we also need the midpoints of each class. So obviously, the midpoint here of 5 and 0 is 2,5, right? Maybe let's write it better. It's going to be 2,5 because we just say 5 divided by 2. And then the midpoint of 10 and 5, it's basically what? Let's just say 10 plus 5 gives us 15 divided by 2. The midpoint is 7,5 here. And then it continues like that. Between 10 and 15, it's just going to be 10 plus 15. 25 divided by 2, it becomes 12,5. All right. Same thing, 15 plus 20 divided by 2, that's 17,5. And then we do the same thing, 20 plus 25 divided by 2, that's 22,5. Then the last one here, it's 30 plus 25 divided by 2, it's 27,5. This is 22,5 there. Nah. So now that we've got our midpoints, we can call this one x if you like. Now we know that to find the estimated mean, it's very easy. 2.5, we know that our estimated mean is going to be all these values that we're going to see here. But they're quite nasty, eh? Quite nasty, it's quite nasty. Let me try and bunch everything together as much as possible. Because it's going to be a long route to freedom. It's a long road to freedom. Okay, so let's go. Now what we're going to do, we take the first one, 2,5, and then we multiply by the frequency. And then we add the next one, which is 7,5. We multiply by the frequency. Now the frequency is 11. Then we add 12,5 and then we multiply the corresponding frequency. Then we add 17,5 and then we multiply by its corresponding frequency, which is now 8. And then we add again the 22,5. Then we multiply by its corresponding frequency. Looks like we are in a bit of a situation. So let's do this. Okay, plus the last one, which is 27,5 into 3. Then we divide by the total, which is 50 of those frequencies. And that should give us the mean. So it's just a boring exercise. But you can see here, yeah, there's no moving fast, even if you like it, okay? 2,5 into 3 plus 7,5 into 11 plus 12,5 into 20 plus 17,5 into 8 plus 22,5 into 5 plus 27,5 into 3. That we divide by 50. So it gives us 27 over 2, which is 13,5 kilometers. Remember, this is the mean distance. Okay? So I will accept that answer because it's 5,5. It looks like it's convincing. So I may have done some injustice somewhere, but you get the idea. Here, the impression is for you to know how to do this. It's not about me getting it correct per se, but for you to see how it's done. All right? All right. So guys, we get a mark for the numerator, denominator, and answer. The numerator, you can see yourself, it's complex. Or you can say the numerator specifically, it's basically those midpoints. Okay. And the whole substitution, in fact, not necessarily the denominator, and then the answer. Okay. So that's how the 11 marks are taken in this question. Okay. So guys, by the way, I will try to keep this memo I'm writing here so that if you watch the video, just check on the description. You will find this memo in PDF if you want it for yourself. Maybe you want to go and argue with your teachers or whoever. You want to go and argue with the department. You can even call me. I'll speak for you. Okay. I'm a very argumentative person. I actually chose the wrong profession. I'm supposed to be a lawyer, you know, because yeah, I can really do the lawyering, not the witching, but the lawyering. Okay guys, so that is the story here. That is the story. So let me just label these ones here so that anyone who's going to be looking on that memo could understand what I'm doing here. I'm just going to say that label is approximately 11, or maybe let's write Q1, perhaps it's better. And then here I'm going to write Q2, and then there I'm going to write Q3 so that someone can understand what's going on there. Okay, one needs to understand what up. What up, what up, what up, what up, what up. Okay. Great. So that's the idea behind all of this. So essentially, guys, you will have the memo in PDF format, and you will have the question paper as well in PDF format, so that it's a comprehensive thing now. You see, the channel is getting better. I'm learning how to use these fancy thingies because my problem is just electronics, guys. I am the generation that never saw a computer until they were at university. Thankfully, I had some friends who had an idea, because on my first few days at varsity, they already showed me how to search things on Google. So I was already the master and opening Microsoft Word and typing, because that's what I wanted to learn. I knew my targets. I must be able to search the internet, and I must be able to open the typing program and type. And then I learned all the other things as we went along, PowerPoint presentations. And by the time they gave us a course on that, it was already set in, okay? So I learn quick, I definitely do. But I'm not really that smart after all. I'm just a normal individual who just keeps on trying all the time, all the time. Trying is what I do best. But yeah, I'm as blunt as everybody else. Now let's go. In the diagram, A with coordinates 3 and 4. Okay, good. B and C are vertices of triangle ABC. So we can see here we have some coordinate x and 0 because that's an x-intercept. At C we've got some x value and some y value. Great. AB is produced to S. Okay, great. So that means also at S we've got some coordinate x and some coordinate y. Now D and F are the x and y intercepts of AC. What? Sorry. D and F are the x and y intercepts of AC respectively. Oh, okay. Now F is the midpoint. Now if F is the midpoint, it means this line is equal to that line about this point F, okay? And the angle of inclination of AC is alpha, so it's indicated. The equation of AB is y equals kx plus 3, okay? So we're just being given the y-intercept there, that it's at exactly 3. We don't know the gradient. And the equation of AC is minus 2x minus 2. So that already gives us the y-intercept coordinates, meaning the coordinates of F. All right, so what can we do here? We can essentially work the coordinates of C using the midpoint expression. Fairly easy. We've got the full equation, so we don't need anything. Perhaps we may want the coordinates of D because it's some x value and some y value, but the y value is 0 actually. So we just need to work out the x coordinate. And once we find the coordinates of C, and somehow we find the gradient, but it's going to be easy to find the gradient. We've got a point A, so we substitute point A there. We'll have the gradient as the unknown, and then we'll have the gradient. Then we have the full equation. Then we can work out the coordinates of B. Then we will need some miracle to find the coordinates of S, okay? Because there's no way here we can find those coordinates. Not a big deal. We are told here, first question, show that K is equal to a third. So that's not a difficult question. So 3.1, we know that basically our line AC was such that Y is equal to not AC but BC, 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 BA, even. Okay, let's just say AB is Y equals kx plus 3. Then we know that point A is a point through which this line passes. So it will be such that 4 is equal to k into 3 plus 3. This implies that essentially 3k is equal to 1. Therefore, k is a third. Nice and easy. Okay, so that is the story right there. So basically here we are getting just 1 mark, perhaps for substituting that point, because the answer is already volunteered. 3.2 says calculate the coordinates of B, the x-intercept of AS. Okay, that's easy. We know now that, well, AS is now the line y equals 1 over 3x plus 3, because we know this is AB produced. Then we know that essentially at B, it is such that 0 is equal to a third of x plus 3. We know that the y value is 0, so you know most, this is an x-intercept of AS. So an x-intercept means y must be 0. This implies that basically our third of x is going to be minus 3 over 1. Then I just simply cross multiply the 3 because I'm not interested in any complicated stuff here. This gives me minus 9. Alright? Or you can say you divide by a third both sides, then that will flip. Easy otherwise. But now we were asked for the coordinates of b. So we know that b is minus 9 and 0. That's okay. We can accept that answer. We're getting 2 marks. So obviously we're getting a mark here and we're getting a mark there. The coordinates don't necessarily get a mark per se because remember, question said calculate. So it means show us the path taken. Okay? So the answer is not necessarily going to get a mark. This is why in the instructions you get told answers don't necessarily give you marks. It's sometimes how you get to the answer what matters. But if the marks are enough for everybody, then you get the marks, isn't it? That's easy, guys. Okay, let me not talk too much. But I feel like I need tea now. Now we need to calculate the coordinates of C. Okay, we can see that is very easy. But as you can see, these 4 marks, I know that that point is like that, but we need to justify that. Okay, we need to justify that because what did the question say? Calculate. Now it means everything we say, if there is a calculation to be shown, we need to show it. So we'll start here and say f is such that y is equal to 2 into 0 minus 2. Why is that? This is the y-intercept of AC. Now this implies that y is going to be equal to minus 2. Therefore point F is going to be 0 is 2 minus 2. So that point needs to be shown how it is arrived at. You can't just write it. Obviously in their memos they will just write it because they're not being marked by you. But essentially you are being marked by them. So you have to be able to display that you are a soldier, not a chancer. Okay. Now we can say then, we understand that point C is going to be the point where x at C plus x at A over 2 should give us the x coordinate at point F. Likewise, y coordinate at C plus y coordinate at A over 2 must give us the y coordinate at F because it's the midpoint. Then we substitute C is going to be in that story x at C plus x at A is 3 over 2 is equal to 0. This one is going to be y at C plus 4 over 2 is equal to minus 2. Okay, so what I do here, I just cross multiply that and then I transpose my 3. So I can make a conclusion here that C is going to be, so 2 times 0 is 0. And then remember this is 0 over 1. Okay, it's not 0 over 0. You don't divide by 0. So essentially we transpose 3. So that tells us that this is minus 3. Okay. We do the same here. We cross multiply the 2 and then we transpose the 4. And then what happens? This is 2 times minus 2. It gives us minus 4. Minus 4 minus 4 gives us minus 8. Okay. I can accept those coordinates because this is the point in the third quadrant. Both x and y are negative. So the quality of the answers at times gives you a clue when you are making a mistake or when you are probably committing suicide. Then at least you can commit it knowing that I'm doing it. So when you are doing it, then do it. But don't come and cry on us here and pretend like you didn't know what was up. Yay, you knew exactly what was up. Now guys, the coordinates of F, you get 1 mark because it's not really such a big gymnastic, is it? And then we get a mark for each of these coordinates, provided you can show us the path taken in attaining those coordinates. Perhaps we can give an extra mark here for substitutions. Why not? So can you see, sometimes marks are distributed in that manner. Great, let's move on. We're doing question 3.4. Maybe I'm too relaxed, I must move a bit quicker. Determine, now we are free here. Once the question says determine, we are free to do it our own way, but sometimes it's just going to be another calculation. Determine the equation of the line parallel to BC through point S. Now can you see, we knew we needed a miracle there. We definitely did, because there was no way we would know those coordinates. So it's minus 15 is to minus 2. Okay. So now we want a line parallel to BC. Now BC is this line here. So it forces us to find out the coordinates of B. Okay, well, we will assume that's a straight line. So this straight line must be parallel to BC. Now we've got the coordinates of B, which we found out it's going to be minus 9 and 0. I don't know why I did not update, because it's always nice to do that. So this is minus 9 and 0. So we have got 2 coordinates on BC now, so we can find that gradient and then use the point S to find that equation. So it's fairly simple, it's a standard question. So we can say here the gradient of the line is going to be equal to the gradient of BC. Right, what do we know? It's because parallel lines have equal gradients. Okay, but maybe let me not write too much notations here for the sake of someone who doesn't know what these things are. We know that parallel lines, problem yam kanti isithembanga apha ekubhaleni, parallel lines have equal gradients. Okay, that's the idea behind what we are doing. Now, this implies that the gradient of our line is going to be the y at C minus y at B over x at C minus x at B. What is the y at B? It's minus, sorry, at C it's minus 8 minus 0 divided by minus 3 minus 9 is going to be plus 9. So this is basically minus 8 over A, superb, 6, which if we simplify it's minus 4 over 3. Okay, that's the gradient of the line. We can say then the line is such that y is equal to minus 4 over 3x plus c. Then through that point S, minus 15 is to minus 2. It means minus 2 is equal to minus 4 over 3 into minus 15 plus c. So we know that 3 goes once, goes 5 times to 15. So essentially we can make a conclusion here that therefore our C will be, now minus 5 times minus 4, it's going to be 20. transpose 20, we get minus 22. We can say therefore y is going to be minus 4 over 3x minus 22. That's the equation of the line. Okay. Now, basically, guys, pay attention more to the method, the steps taken, and the logic behind every single move we make. This is a chess game. You don't just move. If your move is not calculated, you are going to drown, okay? Gonna be checkmate soon. Okay. So essentially, guys, how many marks? 5. I know the equation is a mark. I know substituting that point is a mark. I know finding this gradient is a mark. Where else? We can say here roughly, knowing that this is the story, is also a mark. So 4 marks. Where is the other mark? We can give it here. It's fine. We can give an extra mark because we can't give substitutions twice. Okay, we can only do it once. So that's it. That's the logical thing to do. Okay, not a big deal. So let's do 3.5. Now 3.5 says we need to find BAC. Okay, we need this angle here. That's the one in question. So how will we find BAC? Now look at this. So guys, if you look at this yellow triangle, what do you notice? You will notice that we've got an angle of inclination of this line, AC, and we can calculate the angle of inclination of that line, right? And this triangle, we can see alpha is an exterior angle of this triangle. So we just need to calculate 2 angles, alpha and the angle of inclination of AB. And we can use that property that this is an exterior angle of this triangle to work out A. Pretty simple. So we can call this one beta. Okay? Not to it's not beta as in yakak. It's beta. Not beta, but beta. Okay? You're not Leon. So now let's have a look here. We're going to say let the angle of inclination of AB equal to beta. So every time you're going to introduce your own things, guys, please let there be a statement that tells us that. If you don't provide it, then somewhere in your answer sheet, because these diagrams are provided, please indicate it. Don't just show up on the answers with something we don't see in the diagram, something you did not mention. And mentioning it is not enough. Please show it there too, so that no one is saying, what on earth are you talking about? This AB, someone may read it as BC sometimes, and then look in the diagram and see nothing's making sense, and then you end up losing your marks there. But because someone didn't see what you're talking about. You talked about something, but it didn't translate to exactly what it was meant to translate. So please, guys, don't be complacent. I know you are taught by people who are very complacent most of the time. And you learn these things because you think this is the way, but it's not the way, okay? Now I'm telling you. I'm telling you. So you must luister. Must luister or else clap. Let's come. Now let's go. Enough talking bull crap. I almost said the wrong word. When sometimes this logoria is gonna cause me troubles with the students. All right, students, let us continue. Let us proceed. Now we know that We want beta, we want alpha, whichever we start with. We can say now, technically, we know that, okay, we can even play a smart game and say in. You know, almost when you're a mathematician, you take pride in what you do. You make sure you do a clean job, ABC. You're not like a hooligan, a haphazard individual who lacks logic. Being a hooligan is not really bad because you're still a human being, but it's not quite tasty though. For the smart ones, so you don't want to be a hooligan and just give a tasteless display here. You want to give something memorable, something remarkable, something ecstatic, something, marvelous, something exquisite, something, what can I say, man? Almost the English, almost. Yo, Fiat. What am I talking about? Oh, I wish I knew Afrikaans. Benzo papa cool. Okay, masebu papa masenzi maths. Let's stop the paparing. Let's do the mathematics. Essentially, technically, we know that beta, the tangent of beta, is going to be equal to the gradient of AB. Here we don't need to justify that because we said beta is our angle of inclination. Now this implies that our tan beta, speed up. This is what happens. I write badly. What is that gradient? We found it to be a third. That means our beta is going to be the inverse of 10. Of that gradient. Kodwa sanivele kwenzeke intoni kanti? Isaphindeka ayincamile. Sengincamile masiyeni ke. 1 is shift 10 of a third. The third. It is 18.43 degrees. Obviously, we can make it 4 decimal places, 3 decimal places to cover ourselves with the blood of Jesus in case the spirits of the devil try to find us. So we just want to be elusive as ever. That is not an answer. We know also, remember this is maths, guys, with some simple English included. We also want alpha. 10 alpha is equal to the gradient of AC. Again, it needs no second invitation for one to get that idea. It was volunteered that this is an angle of inclination of AC, and we see that that gradient is 2. Therefore, our alpha is going to be the inverse tan of that angle. Let's go shift tan of 2. Usinikeza 63.435 degrees to 3 decimal places. To avoid issues, we can now say finally, then, technically, we understand without a shadow of a doubt that beta plus angle A, essentially. We're talking about this triangle, but let's write it the way it was given to us. Sometimes to just protect ourselves from unnecessary malice, Those guys can be malicious. They can be malicious and very brutal. This brutality is out of this world, is equal to alpha. The reason, this is the exterior angle of a triangle. But now we already stated our triangle, we don't need to say it again. We just say what we say and then we move on. So this implies that beta was 18,435 degrees plus our BAC back, and it gives us 63,435 degrees. Therefore, our BAC becomes 63,435 minus 18,435 degrees. Don't forget the degrees. 63,435 minus 18,435. It gives us 45 degrees. As far as I'm concerned, this is marvelous, this is ecstatic, this is exquisite, this is fantabulous. You can come up with some neologism if you can. Somebody told us that I don't know how many words get added into the dictionary every year, so why not add our own words? We can, because why not? Who said English must be fixed? English is not really a language that developed on its own per se. It has a lot of borrowed words from all around itself. French, Greek, you name them. So yeah, it's like it's close. Sinamagama amaninzi esiwabolekile from Afrikaans, from English, from Sotho sometimes from other Nguni languages. There's just a mixed masala. Finish and clar. Whatever you want to say, cry or you don't cry, it does not matter. It is exactly what it is, and there's nothing you can do about it. All right, guys, this is great. So technically, essentially, that is a mark. This is a mark. And this setup is a mark. How many marks are we scoring? 5 marks. Holy cannoli. I would rather this is 2 marks, because that was a smart way of answering this question. It sounded a bit smartish. Perhaps not necessarily there either. We can say maybe the substitutions, because the final step is answering the question, right? The others were a means to an end. So where's the extra 5 marks? We can easily say, look, the statement and reason is pretty powerful, was it not? And then to actually perform correct substitutions is pretty valid. But to calculate those angles, nah, man. It's a known thing. It's a known thing. But this one could not be known because we're in a section that often ignores the rules. It often ignores the rules. Okay, let's finish this. I'm getting excited, guys. I'm going to go drink coffee and I'll be more excited than ever. Now, 36 says, it is further given that the length of AC is 6√5 units. Now we are to calculate the value of the ratio of the angle of triangle ABD, the yellow one, over the area of triangle ASC, technically. So that means there's a triangle here. Let's draw it. So there's a joining here, and there's these 2 triangles. So this tablet, man, is really a cure, you know. They gave it the right name. It's a definite cure. It makes my work so easy because I like to showcase what I'm doing. So can you see we've got the yellow triangle divided by that. So what is common with these triangles? Angle A. So that ratio is going to work because there's some sign to eliminate. So we remain with the sides. But now we have a problem. We don't know this side. We don't know AB. We also don't know AC. So technically, those are the 2 sides we need to calculate because they kind of granted us some justice here and gave us AC. Otherwise, we would have had to look for that too. Okay. Essentially, we also need more. We need more, we need more, we need more. We need also this side, AD. Okay. All right, okay. That's not too difficult. That's not too difficult. We can do it. But because of the orientation of this triangle ASC, that orientation is already stopping us from using half base times height because the orientation is just wrong. If perhaps one of the sides was along the x-axis or along the y-axis, we would easily do this with our eyes closed, but now we can't. Okay, not a big deal. Let us just do the things that can be done. What else can you do? There's nothing you can do. First of all, let's find the coordinates of D. So usually the last questions are the nasty type of questions because the marks that are given, they don't match the amount of work you have to do. It's always ridiculous. So let's see. D, we know that is such that 0 is equal to 2x minus 2. It is the x-intercept of x-intercept of AC. So which implies that 2x is going to be equal to 2, therefore x is 1. Therefore D is the point 1 is to 0. Now that we've got that point, because this question is the naughtiest, we can say now AD is the square root of x. At some point I get tired of writing formulae. Maths does not really dictate, does it? Yeah, I mean, it's boring sometimes. Okay, let's go about it the easy way. X at D minus x at A all squared plus y at D minus y at A all squared. Okay, we substitute and we run and never look back. What is x at D? X at D is 1 minus x at A is 3 all squared plus y at D is 0 minus y at A is 4. I need my tea, guys. I'm feeling a little bit dizzy-ish now. And when I'm dizzy, I make mistakes. I know it because I start to panic. My hands shake. They don't become stable. So I'm a danger when I am hungry. Keycodes, I'm danger gefar. I am rood. Is it rood? Is it rooi? It's rooi gefar, man. Rooi gefar, that guy. Die man say it's rooi gefar. When this man is hungry, this man is dangerous. So that would be the distance AD. Now we also want the distance AS. So we just have all distances to calculate, guys. So there's no running away, unfortunately. I tried, but I didn't succeed. So it's going to be x at A minus x at S all squared is y at A minus y at S all squared. I can't wait to finish this question so that I can go make my tea, man. My cup of tea, man. This is 3 minus 15 is going to be plus 15 squared plus this one is 4 minus 2. That is going to be 2 squared. So let us see what we get when we try and put that in the calculator. This is going to be 3 plus 15 all squared plus into 4 plus 2 all squared. That gives us 6 root 10. 6 root 10 units. Oh, I get for some reason. 6 root 10 units. You need that. If you're wrong of words, I senzovela nje bese ngiyangixolela ngoba hake mina sengizamile. Hayi, uyayibona masilento lena isisicefe, like serious sicefeza die one escefe maharahara. So this is x at A, y, that's x at B, all squared into y at A minus y at B, all squared. Bafethu. Sometimes you gotta be patient with the process, you know. This nonsense of always being in a hurry is ridiculous and dangerous. It's dangerous. And when danger finds us, we start crying like we didn't invite it. And yet we invited it with impatience. Impatience is the one thing that you must never have in this life. As much as being patient is not that easy. In fact, it's horrible. But what can you do, man? What can you do? When you can't control the situation, you might as well just go with the flow. Must just go with the flow. Can you see we're just working so hard for nothing? Sweet 5 marks. Yes. Oh. Now we can say then, we know that area of triangle ABD over area of triangle ASC is going to be half. Now it's going to be half the product of the two sides, which is going to be AB times AD sine of angle A divided by half AS times AC. Oh, why lo A kodwa vele abe nendlala njengami manje. AS times ke yabona kusoniphaphela ntondini. AC vele inciphe sana. And I got that sometimes I ndim obubhanqa bento. Those things cancel. That's what we wanted, so that we can have AB. Now what is AB there? What is AB there? AB there is 4 root 10 multiplied by AD, we got 2 root 5. All divided by AS. What did we find? Is 6 root 5. Uyaphosisa. Uma force indade. Skarithetsa. Some belief doch. Ubani ngorithetsa biyano. AD or AC ba re file ba re ke 6 root 5. Se ke maketse jwale gore ke tlo inka kae jwale. Ai na se ke kgathetse ke di calculations tse ngata so. Wa bona dintho tse ngata mona di a sepela, di a baleya. Ya, tshwanetse re be jwalo ka nnete, wa bona. Dintho tse ngata fela di etsa dintho tsa teng. Wow. 2 uya high 2 uya high 3. Jwale re qetile. Ai le nako ya teng ke etelele hampe ha ke sa e rata wa tseba. This is 2 over 9. That is the one, guys. That is the ratio. Remember, a ratio is not going to have units because it's unit on top divided by unit below, so they cancel out. Yeah, this question was not nice because of it's a math essay, but it's a fair essay. First and foremost, getting coordinates of D was key. Getting those distances that we were not given is another key. So can you see 1, 2, 3, 4, and then the final answer. These guys are very brutal. Cannot believe this. These ones were silly, man. But again, in your exams, guys, you know you're going to have to work a little bit extra for nothing. This paper is the longest paper. It annoys me, actually. I don't know why they make this paper very long, because it is not necessary, actually. It's not necessary. But they do it anyway. Alright, guys, let me make me a cup of tea, and then I'll sip it along as we do the next section, which is the last section of this paper. Hopefully, we should finish before 2 hours. Alright, guys, so let us move on to the next question. So, I'm enjoying my cup of tea, man. Can I pour you some there? Do you want some? Come get some here. There's plenty for everybody. Senibanga watata omkhulu abancinci bathanda iti. Kodwa sengiyazilumla bafethu, sengiyazilumla ebengisela lento le bengiyinatha. Nekinwa ntwena. Nikusababhala. Empa ka bona hore e tlo mpolaya kusale manyane. Re tlohele ntho tsa batho ba baholo, wa ba? Etsa hore le nna ha ke fihla mono ke le ntate moholo. Ke re ya konketsetse setlogolo sa ka. A konketsetse tie mane. Etsetse ntate moholo a ka o futhumatsa tsa ka hare monna. Ho bata hampe ka ntle ka mona. Alright, guys, let's not talk nonsense now. Time is against us. In the diagram, the circle centered at C with coordinates 2 and P. Okay, that's a question, obviously. We need to find P, it seems. Is drawn. A with coordinates 5 and 1 and B with coordinates -3 and 3 are points on the circle. All right. E is the midpoint of AB. So if it is the midpoint, it means now that AE is equal to essentially BE or EB. Okay, that's not a big deal. So it already tells us that we can find the coordinates of E. Okay, some X value and some Y value, which we can really find easily. Not a problem. Now this one doesn't give us a lot, eh? It doesn't. So that means for us to work the rest of the issues here, we definitely need more information, okay? We definitely need more information. Obviously, we can use the distance formula because we know the radius is the same, but it's going to be a painful exercise with the circle. It's not the nicest. The algebraic thing here is horrible. But it can be done because those are simultaneous equations. If you know how to handle them, go for it. But let's just work it question by question. Usually in this question 4, this is a true question for grade 12s. I wish they could just stop this grade 11 nonsense, because this is all grade 11. It's just a waste of time asking these questions here. This should be the only question in analytical geometry, by the way, because why ask the other stuff? It's not necessary. Gradients, even grade 10s are doing that. Stop it, guys. Stop it. But hey, I know I talk too much, eh? But I'm tlabula ka etshehla hara mahlo mona ke tla bona dintho monna di theosa di nyolosa ekare ke eng ke dinaledi, eh? E be like batle he ho tla jolwa e re pele ba ntlabole he ke thole. Alright, let's go, guys. Let's go. What is the story now? Calculate the coordinates of E, the midpoint of AB. That's easy. E is the point where x at A plus x at B over 2 is to the y at A plus y at B over 2. I can feel my hand is gaining a bit of stability now. See, hunger is a bad thing, I'm telling you. 5 minus 3 over 2 is to 1 minus 3 over 2. So that t was definitely needed. So now this is 1 is 2 minus 1, okay? So now we've got our coordinates of E, the midpoint. So it says fake, masizibhale sibonakale 1 is 2 minus 1, okay? Because who knows, you might need it. So it's only 2 marks, so usually substitutions and answers or the individual coordinates themselves. But when the question says calculate, refrain from just writing the answer. You will lose marks. Be very careful. Now 4.2 says calculate the length of AB. Leave it in surd form, so that's easy. You see, we were calculating distances in the previous question. They are still asking distances. Like, what's the need for this question again? I don't understand it. Sometimes these examiners are really ridiculous. But who cares, man? If the quality assurer doesn't see the necessity to stop this repetition of the same questions, I don't understand why. I mean, we calculated 3 distances there. Why are we still calculating a distance? Aye. Tate Makhamba wa complain alwena man akothule man. Aye. Akothule ntate. Hobane njwale mpama ise haufi le wena. Aye, re ke kope tshwarelo he. Hobane njwale le ntshepisa ka ditlapa jwale. Le batla ho ntlapanyana. Hlomeng ke tla tsoha. Aye, ho lokile he. Ha le thabile he ke dintho tse tshwanang le tsena, empa nna ha nthabise nthwena. Hobaneng ha ke bone hore e hlokahala o kae. Hobaneng ba re etsa so? X coordinate at B, it's minus 3 minus the 1 at A, it's minus 5 squared plus minus 3 minus 1 squared. Sorry, let's get the calculator. Actually, guys, this talking too much gives me a bit of time to refresh my brain. Sometimes when I'm feeling a bit tired or I'm feeling a bit offish, if I talk a bit, then I feel a bit better. So this is 4 root 5. So I start to feel a little bit better. So don't mind my ramblings. Sometimes they're just pure nonsense, you know. So don't take it personally. If sometimes you hear some things that you don't like, it's not personal. You see, bafethu, just 1 mark ispan esingaka and basifuna sonke lespan. This is daylight robbery, God. Determine the equation. Now we are at liberty to do what we want, but obviously anything more than 4 marks is always going to be, more than 3 marks, it's going to involve some calculations. The equation of a perpendicular bisector of AB in the standard format. Now, what do you know, guys, about the perpendicular bisector of AB? If this line is drawn perpendicular to this and it bisects that chord AB, remember AB is a chord of a circle. It means that line passes through the center of the circle. Theorem 1. I was rambling about theorem 1 not so long ago. So this line is going to pass through the center of the circle. And it is a now perpendicular bisector. So it must be perpendicular. Nalo perpendicular wamuvela njengendlela engicaphukisayo nje. Okay, it's a bit better. So Obviously, the gradient is going to be inversely related to the gradient of AB. That's the question that we were supposed to be asked here instead of the distance. I don't understand this, guys. I don't understand these folks. They like to give us a headache. Ne? Okay. Now, if we want that gradient, we know that the gradient of the perpendicular bisector, I'm just going to write PB, not lead in physics, but that PB means perpendicular bisector multiplied by the gradient of AB. Now, AB must be -1. Now we don't need to justify this. The gradient of our perpendicular bisector into, now the gradient of AB, I'm just going to jump in 1 minus -3 is going to be 1 plus 3 divided by 5 minus -3 is going to be 5 plus 3 is equal to -1. Now this implies that we've got the gradient of the perpendicular bisector into, this is 4 over 8, which is 1 over 2, okay, which is equal to -1. Now we can say therefore the gradient of our perpendicular bisector is going to be equal to, flip this, is going to be -2. 2, now we can go on and say then our perpendicular bisector is going to be such that y is equal to -2x plus c. And we know that it passes through point E with coordinates 1 and -1. So -1 is -2 into 1 plus c. Therefore our c, this is -2 to that side, it gives us 1. Therefore y is -2x plus 1. Okay. Easy stuff, not quite a big deal. So I don't know what I was complaining about, because I love to complain. That's why. That one. And the gradient essentially of the AB there is important, and the gradient of this one is important, and then the final answer. But essentially, maybe not necessarily there, but probably substitutions is what matters here. We have to mark them at some point. So 4 marks, easy 4 marks. Now let's do 4.3. So 4.3 says show that P is equal to -3. So this point lies on the perpendicular bisector. That's why they gave us that word, perpendicular bisector. We needed to know that it actually passes through the center. So we know that, well, with this equation, y is equal to -2x plus 1. Now we know that point C with 2 is to P will be such that P is equal to 2 is to 2. Excitement is causing trouble. So this is now -4 plus 1, which is going to be -3. And that's exactly how that is. So essentially here, the mark is on the substitutions. The answer was already volunteered, so it's not a big deal. Right, all right. So this was a good question, as short as it was. So this was 4.4. So when's again, 4.3 la. Yeah. I repeated, okay? 4.5 says, show by calculation that the equation of the circle is this one. Okay, not a big deal. Now we know the coordinates of the center, that P is -3. And if that point B is -3 and this point is -3, it means these 2 points are on the horizontal. So meaning That point is right across the equator. If we say this is the equator, it means if we draw a line from that point here, if we draw a line, that line is parallel to the x-axis, because we can see they are of the same y value from the origin directly downward. So these are some of the things you just want to think about, but perhaps it's not something you want to really worry about for now, but it's just a thought. And essentially it is actually meaningful, it's very meaningful, because now I can use this point to find the radius technically. I don't know why I backed out. Because now it actually gives me what I want. So I know now that this line is basically parallel to my x-axis. Okay, maybe let's put it inside. So those lines are parallel. So if they are parallel, it means the radius is just going to be the horizontal distance between B and C. That's just the story. So it makes life easy, guys. You see, when you realize certain things, now you don't need the distance formula again. You just use what is in front of you. So we know that, well, the circle center C is such that it's going to be x minus 2 all squared plus y minus 3 is going to be plus 3 all squared equals. Now this one, it's as simple as taking the x coordinate at C and subtract the x coordinate at B, because we don't need to be suffering here, and no one must be asking any more questions now. Specificity therefore x minus 2 all squared y plus 3 all squared is equal to, this is now 25. And that is our equation, okay? So always make a simplified version. Don't leave 5 squared unsimplified. As much as it is acceptable, but you need to be a gentleman or a gentle lady, okay? You can't be a hooligan if you're a math student. A math student must be proud of doing maths, man. And, let it ooze from you. Oh no. You see, now I'm overly excited and I'm committing mistakes. Now, that was not the question. We needed to expand it. All right. Okay. All right. This implies that we've got x squared minus 4x plus 4. Plus, this is going to be y squared plus 6y plus 9 minus 25. 25 wamangmazi ku-10 sekelambile nje is equal to 0. This is x squared plus y squared minus 4x plus 6y. And then 9 minus 25. Ithini nalendo, it's 16, and then kuno 4 payan. Wait, it's 25 minus 13. It's 12. So this is basically minus 12 is equal to 0. So that is the one. Okay. They gave us a bit of a smaller nyana challenge. Not a big challenge, but a smaller nyana challenge. Okay, guys. So that is it. Easy 4 marks. I don't know why this thing is 4 marks. Anyway, whatever. Technically, this was a calculation on its own. And then essentially this is a mark now. This is also saying we have a mark there. Right, 3 marks. And then obviously everything else, perhaps the step, the expansion, is a bit of a gymnastic. As long as it simplifies nicely into the final answer, It's okay. Maybe even the final answer might just be awarded a mark. If Jesus is alive, obvious. But if Jesus is gone, I give a word. Segunjalo. So 4.6. All right. Says now calculate the values of t for which the straight line y equals t x plus 8 will not intersect. Now this is giving us the vibes of the nature of the roots, right? But now the nature of the roots here are terrible. And it's 6 marks. Okay. So we don't know the gradient. So basically Tx is the gradient. Yeah, no, that is not a very standard question, is it? It's not a standard question, so kind of overlooked this question. This question is terrible. It's a higher grade. Now I can see it. I can feel it in my bone. It's an Nkinga problem, this one. So I made rambles here and said, oh, this paper was easy. Yeah, standard. And now this question is ridiculous. It's not, I've never seen this question in the curriculum. So now how are we going to handle this business, guys? But at least we know something about this equation. The y-intercept is 8. Now, when we say this will not intersect, it means we need to find a point on the circle so that the tangent through that point in the circle will have a y-intercept of plus 8. So that will give us an idea of how to find, sorry for the noise. This should give us the idea of where this should be. But now we see the y-intercept is positive, so now a bit of thought is necessary. Obviously, we discovered that this is now the equatorial line. I'm going to say equatorial line because this is what I would regard as the equator of the circle. Now we can see that tangents. Now equator means the horizontal line, right? If you know map work and geography. Now we're going to say this is the equator because it cuts our circle into 2 equal halves above and below. And it's effectively parallel to the x-axis. So we can see that tangents on this side of the circle will literally not have a y-intercept of plus 8. No matter what we do. And even including the vertical ones at the equatorial lines, so can you see all those tangents are not possibly going to have a y-intercept that is 8. So we can't be looking for a line that is below the equatorial line. So now this is obviously a question that is not standard. So one needs to be very, very sketchy here, or else it ends in tears. So we're going to spend a bit of time. I can feel it in my bones, so hang on. Now this is clearly saying the tangent could be on this side. Yeah, perhaps it could reach. We don't know how high, but it could reach. Perhaps it's doing that. We can see a tangent on this side could easily do that too. Ne? A tangent on that side, we don't know, but this could be 8. Or it could be up there. Whatever the story is. So that's what we can get here. So, but the question is, how do we find this point? Now this is a bit challenging, guys. Now it's going to be a trial and error of some sort. Ne? Now we've got a few identifiable points. So we know that the tangent at point B is not going to work. So we're not even going to bother trying point B. But we've got 2 points that we know. We've got point A. We can try A. And essentially, we can see that we need to also consider the x-intercepts. We don't know what that x-intercept is. We don't know what that one is. So this looks like a line that would pass through those x-intercepts, essentially, in a way. Because obviously this point of tangents is a bit wideish. Or we could say this tangent is passing through point A, as I said. Probably doing stuff like that. So these are the possibilities for this tangent. And I would doubt if it can pass like that. I really doubt. So let's leave that one and say we've got these two possibilities here for now. But now we need to be very clear about what we're doing. So we don't need this point anymore. Now let's think about it, guys. So let's say our tangent is from the center to that point. Okay? Now we know that the tangent is always perpendicular to radius. So we've got the coordinates of C, we've got the coordinates of A. Let's just explore what would happen for a gradient that is there. So we're going to say, look, I'm just going to explore the gradient at the moment. So it's going to be 1 minus 3, which is plus 3, over 5 minus 2, which is 5 minus 2, which will be 3. So this is 4 over 3. Okay? It's a positive gradient. So that means the gradient of that line is going to be the negative inverse of this. So it's going to be minus 3 over 4. Minus 3 over 4. So that means this is the gradient of that line, the red line, the tangent. Okay, that's the gradient there. And we also have a point through which it passes. Let's see what would be the equation. Y is equal to minus 3 over 4x plus c. We substitute that point. We're going to have 1 minus 3 over 4 into 5 plus c. Then let's see what is this c coming out as. This is minus 15 over 4. When we transpose, it's adding. So 1 plus 15 over 4. What does it give us? It gives us 19 over 4, which is effectively 4,75. So that's not 8. At least we have a yardstick that we are working towards. But obviously they hide some of the information, so you will struggle to find it. So this one is failing the test. Now this is where the importance of rough work comes, because if you don't appreciate what rough work does, then this is where you want to cry tears. Can you see that point fails? Now it means this tangent along that x-intercept is probably the one. Okay? So let's remove this one and focus on this line now and say, look, we will extend this line to some y-intercept somewhere. And then we extend the y-axis. And we want to explore what is that. If this line is a tangent at the x-intercept. Now, first we need to find the x-intercept. So now let's say x-intercept here is such that y is 0. So we're going to have x squared plus 4x minus 12 is equal to 0, because all the y's are going away. So when we factorize this, we've got x plus 2. X, it's x minus 2 into x plus 6. Wait, that was not a positive, so this is a wrong. So guys, be careful on what you write here. I'm already committing a blunder here. So we know that this is going to be x and 6 equal to 0. So 6 must carry the sign of the middle term. So we can see therefore that x is going to be minus 2 or x is 6. So this already means at that point we've got x is 6 and 0. That is important. So we can call that point whatever we want. So we've got A, B, C, E, O. So we can call that point D. Let's call that point D. I'm 10 going by this. 6 and 0. Okay, that is D. So we can say here, therefore, the x-intercept D is going to be 6 and 0. Okay, good. So let's see what happens now. We're just going to explore first before we start running a marathon. So we want to know what is the gradient when this is the situation. So obviously it still is going to be related to the radius at right angles. Okay, so let's find out what is the gradient of that radius first. So we know that the gradient of, let's call that point up there, P, the y-intercept. Let's call that y-intercept P. So we can just simply say, okay, let's not rush to name things. So we're going to say here M tangent times the gradient of the radius. Why do I write full God? We can just say MCD must be equal to -1, right? This implies that the gradient of the tangent multiplied by this one is going to be 0 minus -3 is going to be that, over 6 minus 2, this is going to be like that, equals -1. We can say, therefore, the gradient of the tangent is equal to, then what happens, this is 3 over 4. So this one becomes -4 over 3 as a result. Now let's see what happens when we substitute this point. Here we can say then the tangent is such that y is equal to -4 over 3x plus c, and then we're going to say through point D, which is 6 and 0, it is such that 0 is equal to -4 over 3 into 6 plus c, and then we see that this once, twice, and voila, wavelu -8, wavelu 8 laphana, yewena. So c is going to be, can you see this one? 4 times 2 is -8. That way is 8. Ah, that's the line. So now we know that there we've got 8. Now let's call this point P, which is going to be 0 and 8. So we know that technically a line that is a tangent which has a y-intercept of 8 in this circle actually passes through the y-intercept there. Okay, so that is the story. That is the story. So this works. Okay. We'll find a way of putting structure into this. So we already know the gradient of the other tangent. So basically the gradient of this tangent should be, okay, we can say therefore here y is equal to -4 over 3x plus 8. So that's the equation of the tangent at that point D. Okay, fine. Now we need to find the other tangent, isn't it? Yebo, yes. But now we need to be a little bit crafty. So look, we need another tangent that has that same y-intercept, but passes through the circle as well. So now I just need to adjust. This one is not gonna work. It's not gonna work. Let me try again. That one works. So we want a line, so we can see that it becomes tangential at that point, which we don't know what that point is, but it's clearly there. Again, we know that this is going to be tangential to the circle center. It's going to be tangential to the circle center there, like that. So let's break that up. Okay, so meaning this is a point that is somewhat related to this one that we have, because it has to be directly across that point, but over this. But now what do we know? Tangents from the same point outside the circle have to be equal. And if that's the case, then it means this becomes an isosceles triangle, right? And if this is an isosceles triangle, we also know that if we draw a line from the center, let's choose another color. We know that if we draw a line from that center to that corner there, this is the diagonal of the structure. But notice this. Notice this structure is perpendicular to the other one there. Maybe let's remove these other lines before they confuse us, because they will lead us to some serious problems. Maybe let's remove this one too. We no longer need it. And leave what we want, okay? So essentially, guys, now if you look at this structure, you can clearly see here that we've got an isosceles triangle. Let me show you. So look at that, guys. So can you see the yellow triangle? It's an isosceles triangle. But obviously we don't know this point. This point is not known to us as yet. We need to find out what that point is. At least we know the y-intercept is the same. But now look at this. What do we see? This is equal sides, tangents from the same point. But you also notice here we've got the radii here that are also equal. So this becomes a kite. Can you see? This is essentially a kite. Now we know the diagonals of a kite meet at right angles. Now if you've got an isosceles triangle like that, with the basal side having a line perpendicular to it, it becomes a perpendicular bisector of that side. So we can say safely that whatever this point here is midpoint there, because now we know that this is essentially perpendicular. Maybe let's show it in this manner. So again, we get a perpendicular bisector. Can you see a question in paper 1 that had something to do with triangles and perpendicular bisectors was there? So guys, if you watched that video, I know you ignore these things because you're thinking paper 2 is different. It's not. If you're still writing maths, I would advise you refrain from not checking certain things. See, they brought it again here, because they know you're not gonna think about it. You can see this question was truly unfair. It was truly unfair because it's beyond what you can imagine for a grade 12. And obviously this is also a cyclic quad, is it not? Because that area, that angle is equal to this one. So there's a circle around this thing. So there's a lot of things to consider, but let's forget about that. So now we can see, so guys, you can see that we've got a kite basically. And we know that the diagonals of the kite, the longest diagonal cuts the shorter diagonal into 2 equal parts, okay? And the longer diagonal divides the angles, the opposite angles equally. They are not exactly equal themselves, but it bisects them. And that creates congruent triangles. Okay, but that doesn't help us much. But what helps us a lot is this perpendicular bisector. Because now we need to define this point. So we can call this point G. And say the point where the perpendicular bisector is bisecting that side, whatever we call it, is G. And then let's call this one H. that other point. So that means if we can find the coordinates of G, we can find the coordinates of H. From the coordinates of H, we can work out the gradient of that line because we've got another point there. Once we find the gradient, then we can make a decision as to what should be the values here for this to work. So can you see, guys, it's not so nice. It's not so nice. You've got to think outside the box, if not inside the box a little bit more. Okay, all right, okay. So guys, I don't know how to really put this in words. We can say then, let the y-intercept of the tangent be point P, which is going to be 0 and 8. Obviously, I'm setting up this thing, okay? And the mirror image, or the other point of tangents, I don't know what to call this one. I don't know, what can we say now? Because we need to say a lot of things before we can start talking here. We can say, and there, should I say the corresponding point to that, which is the mirror image? You can just say the corresponding, because now you can say the corresponding point of tangency that is a mirror image of D B H. Okay, we're setting up the mood, guys. I mean, I don't know how else to do this, but this is one of those silly questions. It's an essay on its own, so you can run away if you want, you can stay on if you want, but this is just the way it is. What can I do? You can see I'm even struggling to put words together too. Now we can see we're gonna finish 2 hours here, but it's okay. We are learning now, so we might as well do it, because trial is coming up and the final are coming up. You might find a nightmare like this. This is a monster. This is suplex city. I didn't think there was a suplex city in this paper, but this one is showing me that this is it. Okay, and then we will notice that we can also say, therefore, we will understand that therefore G, I don't know how to put this. We can say therefore, okay, let's just see. What are we going to say? We can say such that we understand that PH is going to be equal to PD. These are tangents from the same point. P. Okay? Tangents, because this is a circle, so we know that Euclidean geometry gives us that property. And it would tell us that therefore P, H, CD is a kite. Now, I cannot overly explain all of these things. We just stop there. If this is a kite, we know that we can use the properties of a kite instead of the perpendicular bisector of an isosceles triangle. If we said this is a kite, we can also say, therefore, let G be the midpoint of HD. Why? We know that the shorter diagonal is bisected by the longer. I don't know, guys. Yo lento anzange ndayibona imaths enjena ndiyayiqala kodwa ke shem sendikupha nje ideas ke mntwana wesikolo, ungabusakhala kakhulu. Ndikupha nje ideas. I'm trying to show you how you respond to unusual things in a way that is still palatable and in fact attractive. You are the one who wants a distinction, so you have to show that you really hunger for it. Okay, now guys that we've set this up, we can see that clearly we need the coordinates of G. Because if we can find the coordinates of G, we can use our midpoint expression to find the coordinates of H. Once we find the coordinates of H, we find that gradient. Here we are interested in the gradient only. And once we find that gradient, we can then decide. Obviously, this is a negative gradient. If we perhaps make this gradient greater than that, meaning a positive gradient for the same y-intercept, that means that line is not going to intersect the circle. Same story, we can see this is a positive gradient. Now if we make this gradient a little bit less steep, now that's a less gradient than this. You can see that for the same y-intercept, a lesser gradient than the one of pH will make that line not to be a tangent. So that is exactly the parameters that will answer the question. But now we have a long walk to freedom here. We really have a very long walk to freedom. But now let's start doing the things that can be done. We can say here, technically, okay, I'm not going to write technically. Now I want the gradient of, essentially I want the equation of this line, PC. And I will also want the equation of that line, DH. Because where they meet is where the midpoint is. I will get those coordinates. From those coordinates, I'll work the coordinates of H and then finally get to the answer. So it's a very painful exercise, unfortunately. So we will understand that technically, we will say here, let's just say PC. PC is such that. Now guys, I'm going to move quick now because I don't have time. So I'm going to say y minus y at C, right, is equal to the gradient here. I'm going to start by saying y at P minus y at C over x at P minus x at C into x minus x at C. Okay, remember these ones, those are your points y1, 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 x1, and this is the gradient. So I'm not interested in suffering any longer by separating things. So y minus that is going to be minus 3 is going to be plus 3. We deal with this one. Y at P is 8, minus 3 is minus 3 is going to be plus 3. Over x at P is 0, minus 2, that is the story. And then we've got x here minus x at C, which is going to be minus 2. Okay, so let's move fast, Buffett. Let's move fast. Sena skati manje. Skati sesliwe yinja. So this is basically minus 11 over 2. X plus. Now this is going to be 11 times 2 is going to be 22 over 2. Okay, so this is what we have. And then we can say therefore y here is going to be minus 11 over 2 x plus, if it is a plus, let's see, definitely it's going to be a plus. So let's just say minus 11 over 2 times minus 2 before I make a meal. You see, I made a big meal there. I made a big meal. So if we multiply this by 2, it becomes just 11. See, it's easy to really mess up here. It's easy to mess up there. So we can see the 11 minus 3 is what? Is 8. And I don't even know why I did that. But anyway, it comes out nicely. Can you see the y-intercept of this line is going to be 8. So that's good. That's good. Can you see? When you can handle it, please go for it. It's fine. Now, we have to look for the equation of this line now. dA. Because they are equal at G. So let's find DH is such that, now we know that it's going to be y minus y at A is equal to the gradient of that line because it's perpendicular to PC. It's going to be the negative inverse of that. It's going to be a plus 2/11. Sekuyasheshwa-ke manje. So this one is going to be this into x minus x at A. Don't be carried away as much as you are winning, if you are winning. So this is y minus, did I say A, man? Not A, man. This is D, guys. Yo. The point that we know here is D. So this is y at D, which is 0, is equal to 2/11 into x minus 6. All right, so therefore y is equal to 2/11x minus, this is going to be minus 12/11. So that's the line of DH. Hayi bafethu, ayike mhlambe ikhona i-approach engcono kunale. Sekuyi-disaster nje. Asiyeni kodwa. Maths izohlala iyi-maths. So we can say now at G, we know that these equations are equal. So I'm not even going to start saying a lot of things. So I know here that minus 11/2x plus 8 is equal to 2/11 minus 12/11. So this is x. Okay, be careful, guys. The substitutions must be on point. So basically here we can just take that and bring it here. So this implies that we've got 2/11x plus 11/2x, which is going to be equal to minus 8 minus 12/11. Simplify. Unfortunately, kuyafiwa nje. Kuyazifelwa nje la kwelikhaya. And there's so much room for error at this point. This is 125/22x is equal to minus 8 minus 12/11. So this gives us a minus 100/11. Okay, and then we then divide by this fraction, we find our value of x. So this one divided by 125/22. I'm getting a minus 8/5. That's quite convincing. This is literally 1,6. Does it really make sense? Yes, because look at that point. It's before 3. It's before minus 3. So this is 1,6. And you can also see the x-intercept there of the circle was a minus 2 there. Right? You can see this point is... Now 1,6 is not... wait. We are talking about this situation right here. Mag. Khona into engahlangani la. X cannot be negative there. Khona imaths engakhange imetheke kahle ke ngoku. Sekukhona inyakanyaka. Sekwenzeke ntoni ke ngoku? Yane. But this x coordinate doesn't make sense now, because it has to be positive, it can't be negative. I don't know what I did wrong. Oh yeah, when I transposed, wait. I transposed this to this side, that to that side, so this one should be positive. Okay, so guys, interrogate the answers. I'm telling you, when the movements are too quick, they mess up everything. Thankfully, we didn't subtract anything, so now that makes sense. Now that makes sense. It should be 1,6. So even though the calculation is complex, you just have to go with the flow, guys. Okay, sitting over therefore, we can just substitute this into any of the two equations. So I'm gonna choose the minus 11 over 2 into 8 over 5 okay, plus 8. Okay, let's see what this one gives us. So we've got minus 11 over 2 into 8 over 5 plus 8. This gives us minus 4 over 5. Okay, great. So we can then write the coordinates of G, that this is 8 over 5 is 2 minus 4 over 5. Since I'm getting fractions that are realistic, because that is minus 0,8, and we can see this is not far from the origin, so I accept those coordinates of G, so I cannot put them there. But here they are, at least we know. Alright, so now we are almost done, guys. This question was unfair, believe me. Unless there's a very short way and that makes sense. If not, like, no man, literally an entire page, and I'm almost finishing. In fact, I'm done with another 2 pages. Okay, we can say then we know that 2h weight is going to be the x coordinate at D plus the x coordinate at H. In fact, we want the x coordinate of H first, plus the x coordinate of D over 2 should give us the x coordinate at E. Likewise, y at H plus y at D over 2 should give us the y coordinate at E. If you are kalala mntwana esikolo ngalo mzuzu, I won't blame you. This thing is horrible. Plus 6 over 2 is equal to, we got here 8 over 5. And then y at H plus 0 over 2 is equal to minus 4 over 5. Okay, so all I do there is just transpose the 2 there, transpose the 2, cross multiply the 2 and then transpose the 6. Up we just cross multiply the 2. We can say therefore our H is going to be 8 by 2, that is 16 over 5 minus 6. So 16 divided by 5 minus 6, it gives us minus 14 over 5. Now what is minus 14 over 5? Is minus 2,8. You can see that point is definitely less than the x-intercept there, and yet it's less than the x coordinate of this point also. So I would accept this one. 2.8 is closer to 3. So it makes sense, at least according to the diagram. So I'm sure we are doing fine. And then we do the other one here. It's basically minus 4 over 5 times 2. So this is minus 8 over 5. Okay. That also is minus 1,6. So that point is below this point G. So that should be okay. That should be okay. And yet it's above the point C. So that should be okay. We can say then, hayi bafethu angisazi lapha sesibetha ngo therefore abayi 100 manje essay seyimoshakele. Therefore the gradient of HP, the laptop, is going to be, ansezubhala, okay, masibhale ngoba sesibhalile, y at P minus y at H over x at P minus x at H. Sesiyibhalile essay bafana sekuvele nje washayeka konke nje lapha phansi. Sithi minus is going to be plus 8 over 5. Let's extend the division line because it's going to be horrible. X there is 0. Minus, that one is going to be plus 14 over 5. So let's find out what is that. Clean it up a bit. So 8 plus 8 over 5 gives us 48 over 5 divided by basically 14 over 5. So we divide this by 14 over 5. So I'm getting a gradient of 24 over 7. What is that? This is basically 3,4322 decimal places essentially. And that's a positive gradient and it's pretty steep, so it makes sense for me. 3 is pretty steep, so that would make sense for that gradient. And if there's any doubts here, we can find out if this gradient for this line, since this balega cool out to see check and just to be sure, we are saying y is equal to the gradient, which is 24 over 7 plus c. Use that point h. Or point h where to this is minus 8 over 5 equals 24 over 7. X there was minus 14 over 5 plus c. Let's see if the c comes out as 8. If it doesn't, then kuyafiwa bafana. Sesingabafileyo nje sesifanele nje siyolahla emgqonyeni yayiqonda lento. So awuthi siqalela sithi 24 over 7 into minus 14 over 5. This is 48 over 5. Izodluliye ngapha sithi times minus 1. We get a positive 48 over 5 and then we subtract 8 over 5 from that. It gives us 8. So it proves that indeed this gradient will pass through point P. So then I know this gradient we calculated is correct. Finally, we got the story we want. We can see that, guys, this gradient is a steep. So now if we make it less steep, we're making it gentler. So we can see that when the value of t is less than this value, then that line that passes through that point will not become a tangent here, or a secant for that matter. So we can say, therefore, we can see that t must be less than 24 over 7, or t, we saw that the gradient of this line came out to be, what did we get? It was 4 over 3, all right? I mean minus 4 over 3. So we can see that that's a small gradient, so we must say this one must be greater than minus 4 over 3, because a negative gradient becomes greater when you make it gentle. It approaches 0. But when you make it more steep, it becomes more negative. So that's why we are choosing that. So let's write nicely. This is minus 4 over 3, okay? So basically the answers here are from these two lines. This one as in papela, man. That one and this one. Oh, my lord, my lord, my lord, my lord. So the answer came through these situations here. And it was quite a walk to freedom. Now remember, guys, there's a notation here that you can actually put these answers in. You can say T must be less than 24 over 7 in ascending order, but must be greater than minus 4 over 3. That's the final answer. Hi guys, la uyazibonela now, but there's a lot of geometry that needed to come in, a lot of understanding of geometric figures, and considering now the circles together with this, tangents and stuff, congruent triangles, perpendicular bisectors, diagonals of a kite, you name them. There's a lot of geometry, so this question is unfair, but probably there's an easier way to solve it. Now what comes to mind also is the fact that if this line is equal to the circle, we can just check when we take this y value here. Remember, the y value is equal to t x plus 8. So basically, if we take this and substitute for y in this equation, then we will get a quadratic, and then we know that the tangents are always equal to the particular curve at the point of tangency, such that there's only one root because it just touches at one point. So there's one root, and therefore you can check the discriminant delta for it to be equal to 0. So basically you check b squared minus 4ac equal to 0. So if you remember some of the videos I have shown you on algebra, I think it's one from the Free State, if not KZN, I showed when a tangent is to be considered and you have to look for a variable of the y-intercept of that tangent. You can actually use the nature of the roots by equating the two equations, the curve and the tangent, and you get a quadratic expression. You solve it in the standard manner, and you can actually get to that answer without looking for the point of tangency. So that could work, but obviously with the circle it's going to be a painful exercise for sure. So try it out and see if it is not shorter than this method. As you can see, we spent another 30 minutes literally doing one question. And I don't understand how is this thing 6 marks, truly. It's ridiculous. But let's try to mark this for 6 marks then. First of all, we needed to find this x-intercept. Usually, they know the answer is staring at you, but it's hidden, because that's another indirect way of asking you to find the x-intercept of D, I suppose. 2, we needed to find the gradient of the tangent. And for us to be sure that it was the tangent, it had to bring us the y-intercept 8. Because without that y-intercept, we would not have known. We could consider that this line is this line we're talking about. As for the other stories, guys, forget them now, okay? Just forget them. So the gradient and the y-intercept was important. This one was just to set the mood. So this is just me trying to be as comprehensive as possible, because I'm not a hooligan. So I like to explain what I'm doing so that if someone loses me, at least they can see I attempted to direct them. So maybe let's write this one better so that it's clear. I feel like it's gibberish the way I wrote it. We can say the shorter, maybe let's start over there. We can say the shorter diagonal is bisected try the longer one. I mean, this is English, Baba. Whether simple or colloquial, I don't care. But I'm just trying to make sure that when I talk about a point G, you know what point G represents. When I talk about a point D, as I introduced point D there, you know exactly what I'm talking about, and I've indicated on the sketch. You know, when I talk about point H, you can see what I'm talking about. And also finishing the reasons for applying that knowledge. And then we start doing the gymnastics, which now they can make sense to someone because I'm identifying areas that are of importance here. Like PC, you can see it on the sketch. DH, you can see it on the sketch. And then G, you can see that point on the sketch. And. You see, finding the coordinates of G eventually was key here. But now, what was useful here was finding this equation as well. Finding that equation was key. And essentially finding this equation was also key. Now the rest is history, guys. Whatever you want to do, it's up to you, honestly. How many marks do we have so far? We have 1, 2, 3, 4. Okay. 5, finding those coordinates of G. And then 6, finding this. Probably more marks because the answer has to come out. For me, this was an 8-mark question because, yeah, I'm telling you. Because knowing that those inequalities need to come out was key. Actually, these answers deserve 2 answers. So for me, I will mark this out of 8. But we will see what they did when the memos come out. And we will also see if what they did is easy. But I can assure you this is an unfair question. As higher grade as it might be, it excites someone like me, but you can see how long I took to do just this question. And mind you, when you are doing this question, you still have other questions. And usually these are the questions that are dangerous for the brighter students because you will attempt this using every method possible and lose a lot of time. So sometimes when you see something is going to demand a lot of work, even if you have an idea, just jump it. Get the others sorted so that when you come back to this kind of a question, even if you lose time, you're not even sure if you're going to get it right anyway. You just have an idea. But of course, these are the 2 methods. Try using the discriminant and see if it gets the same answers. And if not, try to follow me here and understand my pattern of thought and application of mathematical principles. And obviously these answers check out, so I am sure these answers are correct because they correlate with the diagram perfectly. And we didn't distort this diagram, we just worked with it instead. Alright, okay, so guys, this is the end. I hope this video is going to be enjoyable to those who are discerning and want to understand maths deeper and more. But for those who really want a quick answer, I'm sure I'm not their friend at this moment. But either way, this video's purpose was to enhance your learning and to show you that even what looks unassailable, small ideas, small knowledge, little bits of pieces of knowledge here and there, if you can put them together and string them together nicely, you will definitely have a weapon that can win you battles that you thought you could lose immediately by just looking at how difficult they are. But actually you realize that yes, it's not easy to walk through the battle itself, but when you have a method, you know you are more likely going to be on the other side, a victor. Alright guys, enough of the rambles, enough of the nonsense, enough of the babbling. Otherwise, good luck with your studies, and I will see you when I see you. Sharp, sharp.